Multiplying matrices. This is a little more complicated. All right, this isn't just, line them up, same dimensions, add them up, subtract them, that's it. Okay, it's a little more complicated. Yeah, that's it. At least that's all I got. Okay, your rules for multiplying matrices are as follows. You can multiply two matrices, matrix A, matrix B, if, and only if, the number of columns in matrix A equals the number of rows in matrix B. It's the only way it works. The number of columns in A has to equal the number of rows in B. A is your first matrix, B is your second matrix. When you write that out, and you do it like you write your dimensions, a 2 by 2, a 3 by 4, a 4 by 5, whatever it may be, the inside two numbers need to be the same. That's how you know. Because it goes row by column. Your first matrices columns have to equal your second matrices rows. Okay, that's your set of rules for this one.
Wait, are columns up and down?
Yes. Your resulting matrix, your answer matrix, has the outside numbers of your original two matrices as its new dimensions.
What?
I'll say it again. Your resulting matrix,
So the answer?
yes, has dimensions of your outside two numbers, like how they are over here. So they have A's rows and B's columns. Okay? So, for example, matrix A could be a 2 by 3, 2 row, 3 column. Matrix B could be a 3 by 2, 3 row, 2 column. Okay? Inside numbers are the same, so you can multiply these together. The answers that you're going to get will become, and this is the weird part, a 2 by 2. Okay? This is where you get your funny business going on, because you can literally have two different dimensions of matrices and completely result in a new dimension of matrix as far as your answer goes. Okay?
The inside numbers always have to be the same.
But the inside numbers have got to be the same. Yes.
Okay.
That's the main rule. And it'll at least start to make sense why once we get into it.
Yeah, I want you to work one out.
Yeah. Okay. Everybody good for now.
Yes.
I'm not going to say good period, but good for now.
Yeah.
Okay. So, for example, okay, before we get into this, then this is what I was saying yesterday. It's important to make sure you get your notation for your dimensions and know what your dimensions are, understand rows, columns, that sort of thing, because of this. Okay? So, matrix A is a 3 by 4. Matrix B is a 4 by 2. Can they be multiplied?
Yeah.
Yes. What's your result?
3 by 2.
A 3 by 2.
Okay.
Okay?
The outside.
So it's the outside numbers, correct. The inside numbers match up. Your answer dimensions are your outside, a 3 by 2.
That makes sense.
That's pretty easy.
Okay?
So you don't.
Not yet. Okay? Now, what's 3 times 4?
12.
12. What's 4 times 3?
12.
12. Good. A times B up here on the matrices, 3 times 3 by 4 and a 4 by 2, you get a 3 by 2. Flip it. What's B times A?
Same thing.
No.
2 by 3.
No.
Wait, what do you mean?
If you do B first,
Oh, then they don't work.
it doesn't work. If you do B first, B is a 4 by 2
Oh, yeah.
times A, which is a 3 by 4. Inside numbers aren't the same. Can't do it. So the order that your matrices get multiplied in does matter. Okay, you can't just flip-flop it like you do your normal numbers. Okay, make sense?
So they have to match.
Right. Main point is most of the problems, the matrices will already be there for you. so you don't have to worry about accidentally flip-flopping it, but sometimes you will still see those capital letters in the problems, like you had on the second set of problems for your homework. Yes? No? Know what I'm talking about? Okay. So that right. So then you'd have to be careful with going to put those in. Make sure you put them in the right place.
If it doesn't match, you say can't do it.
Correct. Okay. So number 2 down there, 5x3 and a 5x4. Can you do it?
No.
No. Okay. Good for now.
So, wait, what word do we use? You can't do that.
Undefined. Yeah, undefined. Good for now? Okay. This is one of those slides that's going to freak you out when you see it.
Great.
Don't freak out when you see it. Oh, wait, I don't even put that slide on there anymore because of the freakouts. I was done dealing with it. Oh, goody, go me. Okay. Okay. Fine. It's just 2x2s. That ain't terrible. Okay. Here's how this goes. Find x, y if x equals 6, negative 3, negative 10, negative 2, and y equals negative 5, negative 4, 3, 3. Can you do it?
Yeah.
Yes. Okay, you have x as a 2x2, you have y as a 2x2, the inside numbers are good, you're going to get a 2x2. That can also happen. Alright, 2x2s with 2x2s give you 2x2. 3x3s with 3x3 gives you 3x3 on up the line. Here's how this goes. I'm going to rewrite it so it looks like a multiplication. 6, negative 3, negative 10, it's terrible 10. Let's try that again. Negative 5, negative 4, 3, 3. Okay. So that's going to be like for on your homework with the worksheet. That's the line that's going to be given to you most often. Okay. Now, you're turning this into a 2x2 matrix, right? We have 2 rows, 2 columns, both of them. So your outside numbers is 2x2. So when you make a 2x2 matrix, you have 4 elements. Yes. Okay, now, the creation of those elements, when you go and multiply matrices, is a tidbit complicated. Here's how this works. You take your first matrices row and your second matrices column. Okay? The first row of the first matrix, first column of your second matrix. Okay? Just maybe watch me do this one. Might be helpful, okay? The first number in the first row is what? 6. First number in the first column is what? Negative 5. Those get multiplied. The second number in the first row is what? Negative 3. The second number in the first column is what? 3. Those get multiplied. We'll run out of space. Mm-hmm. It is, yes. But it goes faster once you get the hang of it. So you have the first number in each row and column multiplied together. You have the second number in each row and column multiplied together. You add those products. Okay? You add those products. Alrighty? Good so far? Okay. Let's go make, now we made this one, so let's go make this one. To make this one, same row, next column. Same thing. Same row, next column. The first one times the first one, so 6 times negative 4. Plus negative 3 times 3. And if your matrix was any bigger, you would keep doing that. Okay? You would keep going with that. You would use your first matrices row and multiply it with each column in your second matrix in that manner with element matching element. First times first, second times second, third times third. That's the reason that you have to have this guy's columns equaling this guy's rows. Because that's the only way you can go multiply, 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 multiply like that. Otherwise, you run out of elements in the one. Okay? Make sense?
Yeah.
We'll get to one like that. We'll show you one, how that works.
You just do the same thing with the bottom row?
Now, exactly. So you go through this first row here, makes this first row here. And then these columns go with each column. See how it kind of works? This one stays with the rows. Your first matrix is kind of your rows. Your second one's kind of your columns. This green goes with this column. This one goes with this column. You would keep going until you run out. We ran out. So now we go to the next row. Next row, back to your first column. Same process. Negative 10 times negative 5 plus negative 2 times 3 and then same row, next column. Yes. Until your signs take over on the back end, right? Like it's going to on the white one. You just got, but in between the two products, it's plus. Yes. Let's see where I'm at. Negative 10 times negative 4 plus negative 2 times 3. Okay. Everybody good? This is one of my favorites because it is so colorful, but so pretty. The nice part is, now all that's left to do is clean everything up. Okay, clean each element up. Now, if you want to take, as you get better with this, and then the next one we're going to do, I'm going to kind of do it the way I want to teach you guys how to do it. This is just me showing all the work. I kind of want to skip this step. Okay? And I'll show you how your best bet is to handle that, okay? But this step, I think, can get skipped. Okay, once you kind of get the hang of it and you understand where everything's going, okay? But I show on the first one. Okay? So now you go clean everything up. So do your multiplications. So 6 times negative 5 is negative 30. Plus, I'm going to leave still a plus sign for now, negative 9. You get negative 24. Plus negative 9 for your second element. Your third element, we get 50. Excuse me. Plus negative 6. And then your fourth element looks like we get 40. I don't know why I put that one in parentheses, but whatever. Plus negative 6. And then last step, add those up. So negative 39. Negative 33. 44. And 34. And like I said, if you want to highlight the brackets for your answer, that's good. Alright, same two matrices. This time, we're going to find y times x. So then this is where you need to make sure you put them in the right order. So negative 5, negative 4, 3, 3 times 6, negative 3, negative 10, negative 2. Okay, so make sure you get them in the right order, all right? Now, instead of, and this is going to, if you go back to watch the video, or if you watch the video first, this is going to kind of suck because I can't do this on the video because I don't have 2 fingers, but I need 2 fingers to do this, okay? You still have 2 by 2, so you're still going to end up with a 2 by 2. And I'm making this huge because, okay? Here's how I do this, okay? You have to know that you want this row and this column to make this one, this row, this column to make this one. And you know the process after that. Okay? Here's how I do it. I go first row, first column. -6 or -5 times 6. What's that? -30. And I just write that down straight away. Okay? And then skip that part where you do the -5 times 6 part. See what I'm saying? Okay? And then the nice part is if you know this one's your row and this one's your columns, like if you're looking at your paper, left finger is row, right finger is column. You multiply these two, that gives you -30. You go to your next ones, you multiply those two, that gives you +40. And it's a plus. And then add them together, but save that first step. Get them all filled in first and then go.
So then just write that and then rewrite it.
Right. But see, if you try to do -5 times 6, okay, that's -30 plus -4 times -10, that's 40. Okay, I get that you can probably do that, but once these go into 3x2s and 2x3s and bigger, and you have 3 multiplications to do, like your next one will, then it's kind of a lot to remember. Okay. 2 numbers I could maybe see straight to it. 3, no. So you finish this column, so same 2, go to the next column. -5 times -3 gives you 15. -4 times -2, 8. Add them up. Once you're out of columns, go back to your next row. So 3 times 6, it's 18. 3 times -10, -30. Same row, last column. 3 times -3, and then 3 times -2. And then clean those all up. So you get 10. -23, -12, and -15. So also notice how flip-flopping the 2 matrices, whoops, different colors, gives you completely different answers also, okay? So it's really important to make sure you get the numbers, or the order of these matrices right, if you got to write them yourselves. Anyways, whoops, wrong button. Alright, so let's check these real quick, okay? Shh, quiet. So G times H, do your first row times your first column. So 1 times 2 is 2. 3 times -2, -6. -5 times 1, -5. Okay, so notice how I'm just changing the signs as I go there with this now, okay? So 1 times 3 for the first row, second column gives you 3. 3 times -8, -24. 5 times 7 is 35. So that should be there. Now go down to your next row, but do your columns over again. So 4 times 2, 8. 2 times -2, -4. 0 times 1 is 0. Be thankful when you get zeros in matrices. They really do help a lot. You'll find out more Monday. And then 4 times 3 is 12. 2 times -8, -16. 0 times 7 is 0. Add those all up. So we should, let me put brackets around this, I guess, make it look pretty. So we should end up with what? -9 in the first term, right? 4 down here, right? I don't know why I put.
12. Yeah, it's 12.
Oh, did I get my sign wrong?
Yeah.
-2. -2. I was wondering that because I did it on the.
It's a 12 plus 16 on the other one too.
And it's
Yeah.
-35.
Because I can't see the signs looking at that screen. That's why I'm screwed up. I'm like, these aren't adding up to what I thought they would. There, everything good now? Okay. I was staring at that. I'm like, those aren't right, but I can't see the screen that I look at to do the finger part. I can't see the negative signs. I'm getting old. That's all there is to it. So this ends up to being what? -56. Is that right?
Yes.
Up here, and then this is what? 28. Last one. Oh, words. Words.
Why?
Because.
Well,
Wait, why are we doing this one?
Skip it. I think it makes sense.
Words are unnecessary.
Words, yeah, I know. We
They have
don't.
7, 4, and 2.
Huh?
7, 4, and 2 is your rows, and those are your columns that you multiply into.
Close.
No matter
You're close, but let's double check
What?
what Dimitri just said.
It has to be able to be multiplied.
There you go. Okay, so here's what I'm getting to with the word problem. And Dimitri's pretty close to it. Oh, I'm surprised you can grab that back. At a swim meet, 7 points were awarded for each first place finish, 4 points for second, and 2 points for third. As you can see, the table is set up to have each school in the row and their placings for each place in the columns. Everybody make sense? Okay, see that? Now, find the total number of points for each school and who won. So, you're given each school's first, second, and third places. So that ends up being this nice little cute 4-row, 3-column matrix right there. Okay. Okay. It's a 4-row, 3-column matrix, right?
Faculty and students, just one last.
All right, so you're given you turn those placings into a 4-row, 3-column matrix. Now, as you can probably figure out, your end game here is to multiply each first place for each school by 7, each second place by 4, and each third place by 2. Now, think about this. This is just 4 schools with 3 placings. Okay? Think about this if it was more. Okay? Think about this if we had like 10 schools, we'll go into 5 placings. Okay, Flex?
Do you have a Band-Aid?
No. You can go get one?
Yeah.
Yeah, no. Think about this if this was much bigger than just 4 schools with 3 placings. That would be a lot of multiplying Central's scores by first places by 7. Franklin's first places by 7. Hayes' first places by 7. Lincoln's by 7s. Breeze's by 7s. East by 7. West by 7. Blah, 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 blah. All the way down, however many schools you had. And that's just first place. Then you have second place and third place and fourth place. On down the line that way. This could get very, very big. And it's a lot more of a pain to do it just by doing it in calculator punch, over, punch, enter, punch, enter, punch, enter. Make sense what I'm saying? So, you need to make sure that the easier way, well, I'll tell you this first. The easier way is to actually set it up by matrix. But you need to make sure that that matrix is compatible with what you got. Okay? So you start with a 4-row, 3-column matrix. We have 3 placings. Those placings are worth how much? 7, 4, and 2.
That'd be a 1, 3.
Flip it.
3, 1.
3, 1. Okay?
So it fits.
A 3-row by 1-column matrix. And what does that matrix? What should that order of matrices be?
7,
7, 4, 2. Okay, because think about it when you go through and do this. 7. Well, I can't do the.
7
It would be-
match up with those.
Because the first place when you do it, 4, 8, 10, and 3 need to be multiplied by 7. 7, 9, 5, and 3 need to be multiplied by 4. 3, 1, 3, 6 by 2. 4 times 7. 7 times 4. 3 times 2. And then you would do what between those 3 products? Add them. So right away, once you do that, you have the grand total of points. It's not that you got the first place points, the second place points, and the third place points. You have the school's grand total of points because your resulting matrix will be a 4-row by 1-column matrix. Okay? Makes sense. Cool. It would. And this would be one that I would say use your calculator on. Okay? It really would. Especially if you got to be like we said, like a 10 school with 5 placings. They kept track of 5 placings instead of just 3. Okay? So one like that, you know, and it would be in the directions too. Use calculator. Use it to figure it out. Okay? I don't even remember, and we don't. So Hayes is first, Franklin second, Central third, Lincoln fourth.